Hello everyone, welcome to the Stats Corner. Question 6 says that let x1, x2, x3, xn be IID uniform 0, 1 variates and a random variable t given as minus log of product of these random variables. Then what is the moment generating function of t? Okay, so t is given as t equals to minus log of product of standard normal variates. To solve this question, we have to understand one property. The property says that if x follows uniform 0, 1 distribution, then minus of log x will follow exponential distribution with rate parameter 1. Okay, suppose we say that y equals to minus log x. So here y will follow exponential distribution with rate parameter 1. So using this fact, we will solve this question. So first of all, we have to use the log property to open this product. Then we will apply exponential distribution property. So t can be written as minus can be taken out. Then log of x1 plus log of x2 and so on up to log of xn. Okay, then t equals to minus of log x1 plus minus of log x2 plus minus of log x3 plus and so on minus of log xn. Now minus log x1 will follow exponential distribution, minus log x2 will follow exponential distribution, minus log x3 will follow exponential distribution, and minus log xn will also follow exponential distribution. So what we can say? We can say that t equals to exponential distribution with parameter 1 plus exponential distribution with parameter 1 plus and so on exponential distribution with parameter 1. There are n terms. Okay, so t is nothing but the sum of n exponential distribution. The sum of exponential distribution follows gamma distribution. Okay, the sum of exponential distribution follows gamma distribution. So we can write t will follow gamma distribution with rate parameter 1 and scale parameter n. Why n? Because we are adding n exponential distributions. So what is the distribution of t? T is actually gamma distribution with rate parameter 1 and scale parameter n. Now the moment generating function of gamma distribution is 1 minus t upon lambda to the power minus n. Okay, this is the moment generating function. What is t? T, what is lambda? Lambda is rate parameter. And what is n? N is scale parameter. So in this case, we have lambda equals to 1 and the rate parameter n is n. Okay. Now moment generating function of t will be mt of t equals to 1 minus t upon, we can put 1 on the place of lambda and it will be minus n. So the moment generating function of t will be 1 minus t to the power minus n. Okay, next question. Question 16 is saying that the moment generating function of x when x follows chi-square with 10 degrees of freedom. If x follows chi-square with n degrees of freedom, then moment generating function of x is 1 minus 2 to the power minus n by 2. What is n? N is the degrees of freedom. Okay, so whatever is here in the bracket, it is known as degrees of freedom. The value of n is nothing but 10. So we can put the value of n in this moment generating function. We'll get minus 10 by 2. So the final value will be 1 minus 2 to the power minus 5. Next question. Question 25 says that if x1 and x2 are IID normal 0, 1 variates, then what will be the characteristics function of the product of x1 and x2? So this is very well known fact that if x1 and x2 are IID normal 0, 1, then their product x1 and x2 will have distribution symmetric around 0. Symmetric around 0. And the characteristics function of x1 and x2 will be 1 upon under root 1 plus t square. Question 40 saying that if moment generating function of a distribution is lambda upon lambda minus t, what are the mean and variance of the distribution? So when we see this moment generating function, we immediately think that this moment generating function is from exponential distribution. So if x follow exponential distribution with parameter lambda, then moment generating function of x is equals to lambda upon lambda minus t. Okay, so mean of exponential distribution is nothing but 1 upon lambda, and variance of exponential distribution is 1 upon lambda square.